Welcome to lecture 13. We are studying electronic devices and circuits. Today we will apply AC analysis on BJT fixed price configuration. In the last lecture we have studied this circuit and have talked about a little bit about this linear circuit model of this fixed price amplifier. We also talked about the coupling capacitors C in and C out, that these capacitors block AC from entering into this Vs, the source, and from entering AC into this load resistor RL. And this configuration is used to amplify both voltage and current. We'll see in coming lectures. Today we talk about a little bit more about this linear circuit model. Why do we make this linear circuit model? So that we can apply linear circuit theorems, laws and theorems like Ohm's law, Kirchhoff's voltage law, voltage divider rule, current divider rule, etc. So this model is the AC equivalent model of this circuit. We talked about this in the last lecture, that this C in the input capacitor acts like a short circuit for this AC source. And at this point, the AC has two paths. The AC current flows through RB to the ground, and according to superposition theorem, this acts as a ground when we apply AC analysis. We keep only one source at a time. So the current flows to the ground terminal through this resistor RB and flows through this base emitter terminal. Small re is the junction capacitance of this forward bias junction, and it is on the emitter side. If you see it on the base side, we have to multiply it with beta, and the resistance on the output side when seen on the input side is multiplied with beta. We have talked about a lot about this fact in our earlier lectures. So what RE is the emitter resistor and is written to be feed thermal over the DC emitter current IE. Vt is the thermal voltage and is roughly 26 millivolts. So in practical circuits, we'll see that we'll calculate RE by dividing this 26 millivolt by the DC current IE that flows through this emitter terminal to the ground. So it's easy to compute RE. Another fact about RE is really very small. It's really pretty small resistance. Next, on the output side, we have a current that flows from the collector terminal to the ground. We see a ground from RC. This current source IC is beta IB. It goes from this collector terminal. This is the emitter terminal. The current flows from collector to emitter through RC to ground and through RL to ground. So it has three paths. This is base terminal. So from collector to emitter, we have a current IC which is equal to beta IP. We already know that IC current is beta times the base current. We have a resistor R0. R0 is the collector to ground resistor. R0 is computed from the output characteristics of the transistor. We have studied output characteristics in our earlier lectures. If we extend these lines on the opposite side to the negative VCE, they all converge to a point, we call it early voltage, VA. R0 is VA plus the operating point VCE over the operating point IC. R0 is a very large resistor. Generally it's very large compared to RC and RL. RC and RL are our externally connected resistors. This RC appears to be RC and RL. We talked about this in our last lecture, that RC and RL appear to be in parallel with each other, because this RC, from this collector terminal we go to ground through RC, and this C out happens to be short circuit for AC, so there is a path to ground through RL. So in effect, for AC, RC and RL, they appear to be in parallel with each other. Therefore we have drawn it like this, and across RL we have to compute the output voltage P out. Let's talk about the input and output impedance of this model. What's about the input impedance of this model? To find out the input impedance, we remove this source and find Z in here. If we see it from here, we see RB and beta RE in parallel. So Z in is RB in parallel with beta RE. Since RB is very large compared to beta RE, in most of the practical cases, Z in is approximately equal to beta RE. What's about the output impedance? To find the output impedance, we find it here, C out. And the internal resistance of this current source is very large, therefore we replace it with an open circuit. Right. Now if you see from the output side, we see three resistors in parallel. RL in parallel with RC in parallel with R0. Since R0 is very large compared to their parallel combination, therefore it's approximately equal to RC in parallel with RL. In the next lecture, we'll find the voltage and current gain of this fixed biased BJT based amplifier. Thank you.